This morning we welcomed the Young ICT Lady of the Year on stage, and now we will welcome the ICT Woman of the Year on stage. It's Annemie Depuydt, CIO of the KU Leuven, and together with her colleagues, Leen and Ingrid, they will try to convince us that supercomputing is not something only for very clever researchers, but it's for everybody, and especially for startups.
Good afternoon, everybody. It feels great to stand amongst all these great and mostly female speakers today. And I'm glad Leen and Ingrid, two expert women in supercomputing, are joining me on stage. The message that we want to bring today is that supercomputing is not for rocket scientists anymore. If you mention the word supercomputer, many people automatically think of extremely complicated machines with flashing lights, solving complex problems only geniuses can understand. And that's not longer true. Let's start by defining what a supercomputer is. Oh, I have to switch. Supercomputers are the biggest and fastest computers right this moment. So you could say that once upon a time, the abacus was a supercomputer. When they flew to the moon, they used a supercomputer the size of your smartphone today. And today, the fastest registered supercomputer stands in China and has 34 petaflops. A flop stands for floating point operations per second. So the definition of a supercomputer is constantly changing. It's a moving target. It's subject to inflation due to Moore's law. Moore's law was never a physical law, but a self-fulfilling prophecy from the technology industry. It states that the number of transistors in a circuit doubles every 2 years. So the supercomputers of today will become commodity in the future, and you will hold them in your hands. Be prepared for them. The future looks very interesting. Some predict the end of Moore's law, and meanwhile, the exascale race is continuing. And perhaps within a couple of years, we all will be using quantum computers where bits become qubits with many states. Back to today. The Tier 1 supercomputer is being built in the data center of the KU Leuven as we speak. But what makes that a Tier 1 supercomputer? This is part of the European supercomputing ecosystem, a Tier 0 system that are the systems at the European level, and they are exascale computers now they are most petaflop systems. Tier 1 systems are at a national level and now have many hundred of teraflops, and Tier 2 systems are at an institutions level, often universities. Typically, you start a project or you start to deal with a problem in your own local environment. Once you reach the limits of this environment, you move up. This way, the ecosystems try to ensure that the thresholds for experimenting with supercomputing are as low as possible. High-performance computing is the use of parallel processing for running applications more efficiently and quickly. Supercomputers are often using parallel processing. A problem is broken down into discrete parts that can be solved concurrently on different processors. The past couple of years, we observe the shift from high-performance research computing to high-performance business computing. In the research world, we had the bigger, faster, more mantra. Now, many new business processes are supported by HPC. Many organizations consider supercomputing as an essential part of their business success. Your competitors are using HPC right now. They design new products, optimize manufacturing, and so on. They simulate everything. Studies prove that these companies do get a considerable return of investment for every dollar they invest in supercomputing. Supercomputing is changing the world, and high-performance computing may very well be the new secret weapon. It's a great way to cross boundaries and try new and exciting things. And Ingrid will show you some examples.
So, thank you. So, first example is one of the classical HPC examples, that is space weather. What we look at the sun, we see we get light, warm, but what normally not everybody knows that is the sun is a very active planet, a star, and sends to us a lot of magnetic fields. The Earth is partially protected thanks to some coverage, but not always. And the effects of these space weather events can have enormous losses in systems like satellites, electric network, etc. Every year it's accounted that not even the severe space weather events, but normal events, cause about 10 billion euros per year in Europe based on damages and losses. So what this group is doing based in observations and simulations, trying to create long-term weather forecast, space weather forecast, that can help us to prevent and to get on time the weather forecast to prevent the damage. This is normally requires a lot of simulation, a lot of computer power, and normally about dozens of them, because the important key is to get the result as fast as possible, to being able to get the result before the event happens. And actually, this is a message for the entrepreneurs in the audience. There is a big market there for creating applications based on these simulations and commercial applications for companies that can use this. So get tuned. Another example, also would say classical HPC, but in this case for commercial usage, is what the company E3, that is a Belgian company for the consultancy in environmental design, does. What they do is creating a long-term forecast of the wind in the onshore and offshore, and then they can already have an overview of, in 10 years, in this particular place, what is the wind pattern I will have? And that can help the people that is building wind parks to decide, is this a good place or not? And there is risk, I will have a very good position. I can already attract investors in my project because I have the results. So this company does these simulations for the people that wants to start a wind park. And one of the important things here is the use of HPC has allowed them to reduce the costs. And with the cost reduction, they could make a difference and offer a product that has, in a very competitive market, make a big difference for them. And this is interesting. If we move a little bit, maybe not that clear or not that known, another example is how the analysis of the pesticide spray drift in the trees. So we know that excess of pesticides in the products, or the water contamination because of the pesticides, or other or people that gets during the drift exposed excessively to the pesticides can have health problems. So here, using HPC and CFD simulation, they can create different scenarios depending on how we drift, we can see what is going to happen with the pesticide environment. This way, with this understanding, for instance, you can create rules for how the drift must be done, how the spray must be done to reduce the impact on the environment. And they use HPC for that. Another that's also, I would not say classical, but it's something in the middle, is the genetics. We know the genomics in 2013, for instance, was the first time that the human genomic was, after 13 years effort, international effort, and more than $1 billion investment. Nowadays, we can do a full genome, a human genome in few days, and it costs about $1,500. But human genome is important, but also plants and animals genome is also important. Why? Because if we understand the genome of the plants, we can also understand and create better products, better and environmental safety solutions. This is an example of the pine, a maritime pine. Is a huge genome, is about 8 times bigger than the human genome. So that creates some challenges for the determination. And for that they use HPC and especially big memory systems that can allow to deal with the 7 terabytes data that maybe for big data scientists here 7 terabytes does not look a lot, but we can discuss maybe what big is, how big is big in this case. So, but for them it's really a challenge and they use HPC for handling it. Finally, and this is an example that is about 2 months ago, that go for the new usages of HPC, is the AlphaGo project. That was, I think everybody knows about it probably. Google DeepMind has created a tool called AlphaGo that beats for the first time a professional Go player. Important thing here is, a lot of people maybe don't know, is the extended usage of HPC they did. Not only for the game itself, when they, during the game it was used about 2,000 cores, more than almost 300 GPUs, and so in the Google Cloud facility. But what is important is during the training, and the training, the algorithm mix neural networks together with Monte Carlo trees. They were using a mix of self-training together with analysis of all the plays of professionals. And the usage of HPC during the training was also, hasn't been published, but was extremely high. And a lot of experts say that that's the key difference of why this project is important now, is because the combination of the new algorithms in AI, together with the extensive usage and the availability of these HPC HPC resources, make it possible something that was impossible 10 years ago. And Google DeepMind claims that they have used generic algorithms. So this means, if that's true, that these algorithms can be used not for solving or beating in the Go, but it can be used for solving real problems, environmental problems, health problems. So these open really also a big amount of opportunities. So actually, we have HPC in our lives much more than we think. Yes, I do have one of these things that controls my activity, and now is using analytics for deciding if this accounts or not in my day goal. When we go to the movies, animation movies, special effects, etc. Also, this morning, we've seen a lot of examples about data science, and they didn't say anything, but I'm sure behind, they have used any kind of HPC, from the small ones for the big ones. So HPC is there, and if you want to be the next HPC a successful use case in our presentation, just pay attention to what Len has to tell you about the opportunities.
So the good news is Flanders is investing in HPC. The Flemish Supercomputer Center is a virtual organization in which the 5 Flemish universities participate. The mission of the center is to provide HPC infrastructure and expertise and be an important enabler for research and innovation for universities, but also, and very important, for research centra in industry. The main question probably is why should I, as a new startup company or a bigger company, use a general purpose machine used by many others? And what is now the difference between the Flemish supercomputer and the general cloud offerings? Well, normally, before you start, you have to worry about a lot of things. You have to worry about machines, about machine rooms, but also about installation of software, find and train personnel. This is done for you by the VSC personnel. Normally, you would buy a machine that is or too big enough to run your larger simulation, or big enough to run your larger simulation. That machine will be idle most of the time. Or you would adapt your ideas to the size of the machine that you can afford. In the VSC, we have flexible resources to your disposal. Machines that are in the top 200 of the world, and we invest every year in the infrastructure infrastructure that the users need. Over Flanders, we have a lot of different architectures in place, so you will find a machine that is specialized for your needs. You pick what you use at a certain moment, and you only pay the cycles and the storage you used. And of course, making an effective use of the machine needs insight in the problem that has to be solved. The availability of software components, and you need a lot to know about the HPC architecture itself. So it's not good to take your software, run it on the HPC, you have to learn about the machine itself. And this is where the VSC makes the main difference. When you use the VSC, the Flemish Supercomputer Infrastructure, you're not on your own. We can provide consulting, training, code optimization. We can do your code. We take your code in our hands and we try to optimize it, adapt it to your needs. We not only provide machines, but we provide an ecosystem with a variety of expertise that is at your disposal. And of course, we are inside of the universities. We can connect you with the experts, with the scientists in the universities that are working in your domain. Startups are made to grow, and we are willing to grow with you. We can help you make use of the free testing offer. So every startup can come to us and test their software for free. In this phase, we work together in finding and adapting the software you need. When you are in the research and development phase, we can offer you academic fees. And once you are really in commercial or production phase, you only pay what you are using. So we are convinced that using HPC can boost your ideas and make the difference that is so important for you and for your success. The only question for us is, of course, when do you start? So if you want more information, if you want to brainstorm about HPC, or if you want to talk about us, what HPC can do for you, please contact us. We also brought some folders. You can find us and take some. Thank you.